Let's look at using scientific notation in calculations. In these two examples, the original numbers have already been written in scientific notation for us, but often we will use scientific notation to do calculations with very large, for example, this top number, or very small numbers, this bottom one. So if your number isn't already in scientific notation, but in ordinary notation, but is particularly large or small, your first step will be to convert it to scientific notation. Once we're here, we can play around with this a little bit. Hopefully we're starting to get comfortable with exponents, and you might recognize what's going on here. We have 7.907 being multiplied by a base raised to a positive exponent, and then the number 4.103 multiplied by that same base, this time to a negative exponent. And we know that we can break up this fraction 7.907 into two separate pieces. Let me just write it out and we'll talk about what I mean here. So I can rewrite the original question as the numbers before the base 10 to the power of either 7 or negative 5, and then collect the base 10s together. This works because when we multiply, we're simply going to take the numerator in the first fraction and show it as being multiplied by the numerator in the second fraction. What this lets me do is it lets me estimate what the answer might be. Now notice that 7.9 is approximately 8, and 4.103 is approximately 4. So my answer is 8 divided by 4. It will be approximately, I'm just estimating here, approximately 2. That's the first fraction. And that 2 will be multiplied by 10 to the power of 7 divided by 10 to the power of negative 5. Looking just at this piece, that can be short formed as 10 to the power of 7 minus negative 5. When we're dividing the bases, we subtract the exponents. 10 to the power of 7 minus negative 5 is 10 to the power of 7 plus 5, or 10 to the power of 12. Taking a very large number and dividing it by a very small number, and we're left with an even larger number. So the answer will be approximately 2 times 10 to the power of 12. Now we do want to write what the exact answer is, so if you punch 7.907 divided by 4.103 into your calculator, you'll find you get 1.927. And of course, 10 to the power of 7 divided by 10 to the power of negative 5 is still 10 to the power of 12. Of course, you can do this directly with your calculator. You'll have to find out how to punch in 10 to the power of in your calculator. This could sometimes be the EE button, sometimes written as 10 to the x, alternately written as an exponent as EXP. It'll depend on which calculator you're using, which buttons you need to press in order to enter 10 to the power of that. So take some time to play around with that with the calculator you're going to be using. I've given the final answer here to 3 decimal places because both of my original questions have 4 significant digits or 3 decimal places, and my answer therefore has 4 significant digits, which in this case is equivalent to 3 decimal places. On a test, it'll be indicated how many decimal places you should be rounding to. And we'll leave the discussion for significant digits for another time. Let's look at the second question. 2.8 times 10 to the power of 3, so a large number in the order of 1,000, plus 1.1 times 10 to the negative 2, so plus a really small number. So a really large number and a really small number added together isn't going to change the value of that large number very much. It's particularly not when I'm only using 2 significant figures. I'm taking that numerator and I'm going to divide it by 3.15 times 10 to the power of 4. Here's where we need to remember our order of operations. Because the two numbers 2.8 times 10 to the 3 and 1.1 times 10 to the negative 2 are grouped in the numerator, we have to do this addition first before we can consider the division. There's no magic that we can do for addition, right? The tricks that we played in this first question, where we were able to regroup our fraction into 2 fractions, can't be done with division. So you will have to just punch these numbers into your calculator. 2.8 times 10 to the power of 3 plus 1.1 times 10 to the power of negative 2. If you round that to 2 significant figures or 1 decimal place, you get 2.8 times 10 to the power of 3. 1.1 times 10 to the power of negative 2 is such a small number that when we add it to 2.8 times 10 to the 3, we really don't make a difference, a meaningful difference to that value. All right, so there's my intermediate step. That is a critical one because we need to ensure we're following order of operations. Now that I have a single value, or I can think of it as two values, 2.8 and 10 to the power of 3, but two values multiplied together in the numerator and two values multiplied together in the denominator. If I'd like, I can split this up into two pieces, and that helps me to estimate the answer. Right? 2.8 divided by 3, that's a little bit less than 1. That's kind of like taking 3 and dividing it by 3. So that'll be roughly 1. So approximately we'll have 1 times 10 to the power of, well, it's 10 to the power of 3 minus 4, or 10 to the power of negative 1. So roughly, our answer will be 0.1. Let's see if we actually get there. That's simply our estimate. Let's make sure we come up with the exact solution. And it is the exact solution that I'm looking for on a test. So 2.8 divided by 3.15 is 0.888 repeating. So at some point we're going to round the last 8 to a 9. And of course, 10 to the power of 3 divided by 10 to the power of 4 is 10 to the power of negative 1. To put the answer into proper scientific notation, of course, I need a number that's between 1 and 9 to the left of the decimal, so the 0 can't count. So I better pick up the decimal place and move it 1 to the right so that I have a value of 8 as the sole number to the left of the decimal. That gives me 8.8, 8 repeating, and at some point 9 times 10 to the power of, well, I've made the number larger by moving the decimal point to the right, but we know that this is a small number. So now I have 10 to the negative 2 to get it back to the original. So the final answer to the smallest number of significant figures in the question, which is 2, is 8.9 times 10 to the negative 2. Again, the question will specify how many decimal places it would like you to round to. Do you need to use all of these intermediate steps that I've indicated here? No, you don't. The critical one is to get to here, to get to the second step, recognizing that we have to do the addition before we can deal with that fraction and do the indicated division. And it's absolutely appropriate to punch 2.8 times 10 to the 3 and 3.15 times 10 to the 4 into your calculator, and it will give you this final answer.